This is solid calcium metal. When it's added to water, it produces solid calcium hydroxide and hydrogen gas. It also releases a lot of energy as heat. We're going to do an experiment to figure out just how much heat it releases. To do this, we'll first weigh out some calcium metal on a balance. That looks like about 1.711 grams of calcium. Now let's get some water into this styrofoam cup. The water will be used to trap the energy released as heat. That's 198.179 grams of water. Before we run the reaction, we need to find the initial temperature of the water. That looks like 29.3 degrees Celsius. All right, it's time for the reaction. Here's our calcium metal, and into the water it goes. Here, check it out. You can see the bubbles from the hydrogen gas being released. We're going to cover the reaction with a second styrofoam cup to try to trap the energy as heat that's being released in the reaction. It takes a little bit for all that calcium to react, but once it finishes, we'll measure the final temperature of the water. Whoa, check it out. It went up to 51 degrees Celsius. We now have the data we need to find out how much energy as heat the water gained. And we're going to use the good old heat equation to help us out. The mass of water we used was 198 grams, and its specific heat is 4.18 joules per gram per degree Celsius. Finally, the water increased in temperature a total of 21.7 degrees Celsius. When we multiply these three together, we get close to 18,000 joules, or 18 kilojoules. Dividing this by the mass of calcium we use gives 10.5 kilojoules per gram of calcium. Finally, if we multiply by the molar mass of calcium, we get 421 kilojoules per mole, which is our measured energy as heat released in this reaction. Hey, just for fun, let's ignite those hydrogen gas bubbles that are produced, shall we?